In this question, we're given a balanced redox reaction, and we're asked about some of the oxidation states as well as to identify the reducing agent. So when I approach these problems, I just start by going through and identifying the oxidation state for every single atom on the left and right side. And that's going to answer the second question for us of the oxidation state. And then it's also going to help us identify where the electrons are coming from in this redox reaction. So let's take a look. We'll start with this chromium oxide. And we know the whole thing is -2. Okay, and that oxygens are all going to be -2. Okay, it's very rare for those 7 oxygens to be bonded to themselves. And so we just default to that, hey, in this, their oxygens will have a -2. And that's one of the core rules that you should remember. Okay, so that's -2 times 7. So there's -14. The whole thing is 2 minus. So I need my chromiums to be a total of +12, and I have 2 of them. So that would be +6. So there's my my second answer, but the first one that I can put in. And then let's look at our nitrous acid. So we've got oxygen again, which is not bonded to itself. That's -2. There's 2 of them, so that's -4. Hydrogen, I'm going to do next. We know that's always +1. So in total, this is a -3 so far, and we know that the whole thing has to be neutral. So each of those nitrogens should be +3. Sorry, all of the one nitrogen in there should be +3. Now we know that these hydrogens, this is being done in an acidic solution, those are all +1s. Now let's look to the other side. Chromium is now +3. That's a monatomic ion. We know that that oxidation state is just the charge. Let's look at NO3 minus. Each of those oxygens are -2. I now have 3 of them. That's -6. The whole thing is charged -1. And so nitrogen in this needs to be +5. And then over here in water, our oxygen, stop shifting on me, please. This is -2, and each of these are +1. All right, so now we have everything we need to know to identify the reducing agent in this reaction. Okay, so when you're asked for the reducing agent, or the oxidizing agent, we're always going to pick something on the reactant side. Okay, so this is like the agent, the reactant that you're going to pick up in your lab and say, I'm going to use this as a source of electrons. The reducing agent is something that is good at giving electrons away, which means that for us, we're looking for something that has a more positive oxidation state on the product side, because that must mean that it lost electrons and it gave the electrons away to someone else. So it reduced someone else, therefore was oxidized itself. So I noticed that as we were going through, that nitrogen over in nitrous acid was +3, but over here in the nitrate anion, it's +5. So it went from +3 to +5, so it must have lost electrons. So I'm going to call my HNO2 my reducing agent, because that's where the electrons are coming from. Specifically, we can say, oh, that the nitrogen was like sort of where that electron density was. But when we are asked for the agent, we talk about the whole molecule that those electrons came from. So this is HNO2. And if you want to be complete with it, where did those electrons go? Well, chromium was +6. And over here, now it is +3. And so each one of those chromiums gained 3 electrons. And so this chromium oxide anion was our oxidizing agent. Okay, so that's how I approach those. Don't try and skip steps, go through and assign, use your oxidation state rules to go through, assign those numbers, and then look for, on the left and the right side of your arrow, who's gaining electrons and who's losing them. That'll answer those reducing and oxidizing agent questions.